Much of the code you write can be tested using mocking frameworks such as Mockito or EasyMock, but there are certain instances where you want to execute code and validate behavior against a database. It is important when running integration and functional tests that the database is in a known state before every test in order to have reproducible tests without side effects. Prior to Spring 4.1, if you were looking for your domains to interact with a database, you could seed data with a tool like dbUnit prior to the application context loading, but it was fairly intensive. In this tutorial, let's find out how Spring's testing improvements has simplified executing SQL scripts and inserting test data into an embedded database. Setting up a Spring Boot project through a starter initializer, selecting Spring Boot Starter JDBC and Spring Boot Starter Web, we will generate and download a Maven project that we will import into Eclipse. Next, adding the HyperSQL dependency will allow us to connect and interact with an embedded database. You are probably thinking we need to configure the database URL, username, password, and driver class. Luckily, Spring Boot will recognize the HyperSQL database classes on the class path and will auto-configure an embedded database, which saves us some work. If you're interested in the lower level classes that make this happen, look at the embedded database connection and the embedded data source configuration. Let's explore the application test class that the initializer created for us. First, the run with annotation states instead of using the default JUnit runner, use the Spring provided class instead. Next, the application configuration will load a Java config class to configure the application context. Our configuration is light, but this is where you can include multiple configuration classes to set up your test. Last is the web app configuration, which just says load it in a web application context, which has some underlying behavior. Let's run the test to validate that the setup is functional thus far. Next, we will need to create two scripts. The first script will contain SQL statements to create a table named person and an insert statement to load Fred. The second script will be executed after test and will drop the person table. As mentioned, we want to execute the before test run SQL prior to any test running and the after test run SQL after each test method has executed. We can do this by using the SQL and SQL group annotation. The SQL annotation can be declared on a test class or test method, allows you to specify a file to be executed against the database. The default behavior is to run it before every test, but if we want to be explicit, we can add the execution phase attribute. Next, we want to execute our second script. Since we are running prior to Java 8, we need to use the SQL group to declare multiple instances of the SQL annotation. Otherwise, we could take advantage of the repeating annotations that come with Java 8. Let's wrap our first statement with SQL group and add our second SQL annotation. You will notice we included the execution phase with the after test method enum so that the script will be executed after each test. After running our test, we can view the logs and see that the scripts were executed. To validate the code, let's write a simple query and use JDBC template to execute. You can see the SQL and SQL group annotation helps simplify populating your database when your application starts and throw away changes when tests end. If you're extracting a DDL or SQL from an existing source, there may be compatibility issues running against the embedded database such as H2 or Derby database. As your tests grow, pay attention on how long it is taking for your scripts to execute in your continuous integration environment to keep builds running fast. Thanks for joining in today's Level Up. Have a great day.